going to share sort of a workflow of how we can pull grids in from Enverus Subsurface Studio to Prism itself. And now this webinar is focusing specifically on CO2 storage grids. And part of that reason is these grids we're making in real time, essentially, to integrate into our analysis. And they're quite new and something that we find are quite valuable when we integrate with the Prism platform to overlay data sets such as emissions, transportation, parcel data, and so forth. But this workflow can be done with any subsurface grids. It doesn't necessarily need to be done with Subsurface Studio, as long as those grids are in sort of an ordered point set, and I'll show you what that looks like in a second here, or shortly in the CSV section. But if you do have Subsurface Studio, there are some advantages in terms of speeding up that grid ingestion into Prism, and I'll go over what that looks like. But I'll also go over the Excel formatting to show you what it would look like if you were exporting these grids from other software. But we can see that our data set is now at the bottom here. And so we can look at this. We have our legend on the left here. So at a 4% efficiency factor, we're looking at 5 to about 34 megatons of CO2 per section storage capabilities. Now, this is great, but how can we use this to incorporate the other data sets and create, I'd say, a really good visualization of everything that's out there? And so this is where I'm going to get into building the workbook and really putting it together here. So I'm going to get rid of these widgets here because I want to add my own. So the first thing I'm going to add here is really looking at the actual subsurface component. And so I'm going to go to our data set, and we can type it in, or we can collapse some of these files, and we know it's under my data sources. I've got a lot of data sources here that I've uploaded, so it's probably easier for me to actually look for it with the search function. Now, we could view this data in many ways if we want, say with this bar chart, or there's, sorry, I should have mentioned a number of other widgets that we can pull up, bubble charts, cross sections. Cross sections are specific actually to specific regions, so we can't pull that up specifically for here. Data tables, heat tables, line charts, pie charts, a number of ways to represent our information. And so again, I'll go back to our Southern Louisiana data set here. So right now our x-axis is on latitude, and this is where that region label comes into use, essentially, because I'm going to in this workflow, I'm going to zoom into specific areas. And for example, we're going to want to know what the average CO2 storage volumes are, maybe what the maxes are, the injection rates, the storage costs. We could look at porosity and so forth. But what I'm going to do here is put the max sand storage costs. And so what this is looking at I'm going to put the region in first on our x-axis. And the reason why we have a region is so that we can attach this data to one bucket. Because if, say, for example, I was to attach, I'll turn this y-axis to storage costs, just so you can see what I mean here. But if I was to attach this to, for example, latitude, in some cases, if your map is bigger, it'll attach these buckets to different latitudes. Let's say if we go isopac, we can see what the CO2 storage volume, what the storage cost looks like, essentially, with different isopacs. And so if we wanted to, I mean, we can look at this data in that way. But if we just want to look at sort of the regional level storage costs, and this, again, can be broken down any way you like with that, the way you've ingested the data, but just allows us to view this in sort of one simple way. And I'm going to, instead of count, this would be counting up all the individual nodes. And so that's not what we want to look at. What we want to look at is the mean here. We could also look at the max, which is just going to give us essentially one value. Sometimes it takes a second to load some of these. But for this case, we'll want to look at the mean. We can group these by different things, but just for the purpose of building the workbook I want, I'm going to start with that. We can quickly duplicate these widgets by hitting the duplicate widget tab at the top here. And so if we want to create multiple widgets of the same thing and just quickly edit them, it's a pretty easy way to do that. So these all are showing the actual storage cost in this whole region on average. So we're looking at about $12.50 per ton. But I'm just going to edit these and add in here the injectivity mean, and so we can get a sense of how much CO2 you can inject per well per year. And then I'm going to add in here as well the storage volume. So we could look at the 4% efficiency factor, 1%. Let's go with 4. Again, we're looking at the mean. In this case, that might not be representative. In this case, we might want to look at the actual sum. How much CO2 could we store in the whole area? And so we're looking at about 419 gigatons, so 419,544 megatons of CO2 in that whole area. So in this whole southern Louisiana area. So it's quite a lot of CO2 that we can store. So that's really setting up the first part of this, looking at the actual storage and the CO2 properties. But in this case, we want to bring in the Enverus data sets to see how we could evaluate a project. And I know project evaluation can really go one of two ways in the case of CO2 storage. The first could be looking at the emitter, especially looking at brownfield emissions. Where are those emitters? Where are the volumes, concentrations, and then what are the capture break-evens of those emissions? Or we could look at storage first, identify where the most prospective storage is, and then go backwards from there and look at the closest emitting sites. So in this case, let's see, we can go. In this case, let's start with the emissions. So we've got our map here. We want to know where the brownfield emissions are and what their capture break-evens are. So I'm going to go to our Enverus. So I'm going to go to our edit order layers at the top of the map here. I'm going to hit, I'm going to look for our greenhouse gas summary. And so this is all our emissions data that we have in the platform. I've turned that on. You can see that they've now come on the map here. The legend has updated with that information. And here we're showing colored by total CO2 equivalent emissions. And so say, for example, we only wanted to look at CO2 emissions, not the equivalent for actual CO2 storage. We have this also broken down into total CO2 emissions. So that's going to populate there. Again, we can do a lot of stuff with this data in the platform. We can change the number of bins, just how the data is being binned here. We can change the values. We can change these point sizes, but we'd have to uncheck auto here. And so I could make these larger or smaller, but I can also size these by something as well. So say, for example, we wanted to look at which sector were these emissions coming from. We can color, first of all, by sector. And then we could size by CO2 emissions. And so that's going to make it so that we get a better visualization of what these emissions look like. And actually, I'm going to reorder these layers. So I was on this tab here. We can see that our map now is on top of these greenhouse gas emissions. I can go to order and change any of these layers around. So let's put these greenhouse gas emissions on top. And now we get sort of a better visualization of where those are. And again, we can see that these are colored by sector. Those sectors are all on the left here. And then again, these are all sized by those emissions. But that doesn't give us a very good, I'd say it's a very good qualitative view, but not a very good quantitative view. And that's where the widgets come into play here. I mean, we can get a sense immediately that we have a very high concentration of emissions along the Mississippi corridor, for example, some here in sort of south western Louisiana. But again, I guess a good way to visualize and potentially zoom into an area where you have a high amount of emissions. But what I can do here to sort of quantify this a little bit better is I can create some bar charts for this. And so again, I'll go to our greenhouse gas summary. I'm going to categorize this by sector. And right now we're sized by the sum of CO2 emissions, but I could also categorize this in a number of other ways, and we can play around with these widgets in a lot of different ways. But just for the sake of time here, I'll pull up this, and so we can see that we're looking at total CO2 emissions by sector. We can see that actually. I'll zoom into Louisiana to get a sense of exactly what these emissions look like. All of these buckets will update again. And because this map was pulled in as a point set, you kind of start to see the gaps between those points. But we could, for example, adjust these point sizes if we wanted to make it look more continuous, for example. But for this sake, I'll just keep it on auto. So we can see that the majority of these emissions are coming from power plants, refineries, petrochemical production, ammonia. And so we can again filter to these. So if we only wanted to look at refineries, we can filter that data set. Again, these are hard to see a little bit, so we can go to the user tab here and change the opacity of our map in the background. Makes it a little bit easier to see these emissions. And again, yeah, we can filter all those out. Another thing that we have as well baked into this is, and I'll duplicate this so that we can quickly build a new chart, but is the actual break evens of these. And so I'll go to our summary here again. I'm going to categorize by, and let's say we want to categorize by the average break even of these. So we want to look at economically viable emissions. And so I can change this histogram, size these by actual CO2. We'll look at equal percentage of data here. And so now I've essentially categorized the emissions by, sorry, I'll go to sum here. Again, sometimes it's just if the data that you're looking at doesn't make sense, it's a matter of, oh, this is OPEX here. Gotta go back to CO2 emissions. Sometimes it's a matter of, maybe you didn't check sum, mean, count. Count would just be actually counting those individual data sets. But we've changed this to sum here. So now we have a bar chart created with the actual break even of these emitting sites by actual volumes of emissions. And so we can see that 10% of our emissions actually fall within a pretty low capture break even. If we're looking at $85 per ton for the 45Q tax credit, I could filter these specifically to, we got about 15.7 million tons per year of CO2 with a capture break even between $21 and $28. And so I could click that, get a sense of which of these, and it's going to update everything here, get a sense of which of these sectors are associated with these low break evens, and also where they are. Everything's essentially updated here. So you can see that ammonia manufacturing, very pure stream of CO2, high volumes are generally going to have a low capture break even. And so now we've essentially identified where those sites are. And so now we could, for example, zoom in to one of these sites. And so let's zoom in specifically to Mississippi corridor here. We have both a high volume of CO2 storage potential. And again, those points in the background have, they're 1 point per square mile. So they've just shrunk a little bit. Again, we could change the size of those to make them more visible, essentially. And so I just had that sized auto, but we could increase that size so that all these points connect to make it, look like a connected grid in this case. And so again, because I've zoomed in, this grid has also updated. But we can see that within this area, we've got about 8 million tons per year of ammonia CO2 coming from ammonia manufacturing. And so now I can specifically hone into this specific area. The first thing I would want to look at, for example, is overlaying the pipe. And so, sorry, I should mention here that I've just reset that capture, capture break even toggle that I had on. So now all our emissions are back. But I can bring on our pipeline data. And so go to pipelines here, because we're going to need to understand, is there any infrastructure in place that can actually take this CO2? And so I've just turned on, and for the sake of clarity, I'm actually going to just turn off our grid. We understand what the storage capability is. These widgets will still stay on even if I remove that visualization. And so that's really what we want to see, and I'll show you what I mean in a second here. So we can see our pipelines on here now. I've also got the emission sources, but see that these pipelines are now colored by commodity. We can change the line width. It's hard to see, just to make it a little bit easier here. But now we see that, we've got a lot of pipe on here. Maybe we only want to look at CO2 pipe. And so in this filter tab on the right, this is how we can filter down a lot of our data sets. And so I'll go to pipelines. I'll go to commodity, because these are now colored by commodity. And I'll filter specifically to carbon dioxide. I could filter to carbon dioxide and natural gas if we're looking at retrofits. But in this case, let's specifically look at CO2. You can see that there is a pipeline here that could be leveraged depending on where our storage site is. I'll just make that a little bigger. It's black, so it's a little clearer to see. Now we can see we have that on there. We could also create widgets with that pipeline data. We've got 20 minutes left here. This workflow's a little bit long. So we could, again, create the same widgets with pipelines. We could filter those pipelines by operator. There's a number of other things we could do with that pipeline data. For the sake of this, just showing how we can integrate the data sets with one another, just filter to those CO2 pipes themselves. And so that's great. We know there's a CO2 pipeline in place. Now let's say we want to choose a specific area that we know has great reservoir quality. And actually, let's turn our reservoir map back on. So we can see that down here, we have roughly, 22 to 24 in this area, megatons per section potential. And so what I can do is say, zoom into an area that's on this pipeline. I can create a boundary. Actually, instead of creating a boundary, there's something better that we can do. Say we've modeled our reservoir properties already, and we know what our area of review looks like. We can use this marker tool here, and now I can click. And so instead of actually drawing a polygon, which we can with this polygon tool, we can actually create just a radius. And this is essentially doing the same thing as drawing one. We could draw freehand with this one, but this one we can actually get a radius. And say we think our CO2 plume, for example, or area of review, whatever the plume or the pressure front is 3 miles. I can change this and apply that. And that's going to show us everything within this essentially 3 mile radius. And I'll just give this a second to update here. Sometimes this just takes a second. Might have to delete this and try that again. Sometimes with these large ingested data sets, it can be a little bit finicky, but so again, I'll draw my area, change that to 5 miles, apply, save. I had 3 miles before. Let's give this a second to save. But we can see now that everything is updated to include just this area. And now I know we had some emissions outside of there that we were looking to capture. This is, again, filtered specifically, all of our data sets specifically to this area. And this is where these charts really become interesting, because now we can see what the average storage costs are specifically within this region, or the average storage break even rather, but $12.30 per ton. we can see how much we can inject on average per well per year in this area. We can also see what the actual storage volume is, it's about 1.8 gigatons within this 5-mile buffer. So one big part of the, actually, sorry, just going to explain what I'm doing here. We've got this sort of green hue over top of the grid. I'm just going to change the opacity of that so that we can see it, change the line width of our area just so it's easier to see what we're looking at. And so here we're looking at the storage volume, but one big part of applying for a Class 6 permit from the EPA is understanding which wellbores penetrate your aquifer. And so in this case, I'm going to turn back on our wells layer. So all the wells have popped on here. I'm going to change our user data set, so our grids data set, to actually look at the depth of the reservoir. I think I've got the base TVD here, the top depth of our reservoir. So this is going to filter that. And we can look on the side here. Our reservoir is about 4,500 feet to 4.5 thousand feet to about 4.8 thousand feet. So we know that any wells really drilled deeper than about 4,500 feet, we might have to, we will have to look at. And so I can change our wells data set. Actually, there's a few things that I can do here. One of them is I could filter specifically to these wellbores. Again, filter that out here. This might take just a second to update. Yeah, so I filtered to our wells here. Again, I could make this a little bit transparent. Oh, it's looking at a different data set, but we have our wells in the background here. I can pull up another widget, for example, to look at the wells themselves. And so we could color these wells by county or even by, let's go by, yeah, let's say vintage. We can color these wells by vintage. And then we could color these wells, or actually rather than vintage, I'm going to color them by depth. So let's look at the, we could look at the TVD. I know in Louisiana, sometimes these wells are actually reported as measured, the TVD is reported as measured depth, just from understanding the data set here. So I'll change the x-axis to measured data. This might take a second to load here. And so what I'm trying to create here is actual measured depth on the x-axis, so we understand which wells are penetrating that formation. I might have to refresh the page here if this doesn't load, or I can show it another way. Knowing that we need to look at wells below 4,500 feet that have penetrated that depth, we can go back to the filter layer here, look at our wells data source, and then actually filter our wells to that depth. And again, using measured depth as reporting sometimes is reported that way. And I'll filter this to minimum 4,500. And so that should update our wells on the left here. You see that it just has, so we have 167 wells here that essentially penetrate our storage reservoir. And so we can take this a step further and understand what the status of these wells are to see if any of these are still producing, which ones have been plugged and abandoned, and so forth. And so I'll just go to well status here. We can see that these are mostly yellow, so mostly already plugged and abandoned. Some of these drilled. Should just delete this polygon here, make it easier to see. Let this update. Oh, I see that got rid of our filter there. I'm just recalculating some of these bins for the map so that we don't have that stripe. But you get the picture. We've now sort of identified the area that we need to remediate potential wells, or at least look at these well bores within this specific area. And now the last step, I know we're getting close to time here. Again, this workflow is pretty comprehensive. The last step here would be to looking at our parcel level information. And so assuming that the surface owner owns the rights to the pore space, we can pull in here our parcels data. And again, this is where the workflow can vary, whether you want to say, look at parcel ownership first, then go to storage, or look at emissions or storage first. There's a lot of different ways that this workflow can be approached. So I'll turn on our parcels data here, and I'll actually get rid of some of these other layers because they can be got quite a bit on the map here. I'll leave those on. Parcels data set's quite large, so I'll have to specifically filter to the state. And so I'll choose parcels here. Right now we're filtered to Texas. That's the if you turn on the parcels layer, that's the one it's going to initially be filtered to. I'll filter this to Louisiana. And then we'll just give this a second to update, because again, this parcels data set's quite large and sometimes takes a second. Sometimes if it hangs up, it works if we save our workbook, and let's save this as Southern LA webinar. Actually, we can see that the parcels actually did load in the back. They're just colored by solar capacity. Let's color these by county so we can see them more clearly. There's a lot of work that's been done on the parcels data set, for example, to extract solar capacity based on the amount of sun that's actually in that area, or wind as well, based on wind, the amount of wind in the area. We can see that we pulled on the parcels data set here. And one really cool thing that we can do now is create a widget with those parcel owners. So I'll create another row chart here. Just give this a second to load. Try pulling this up one more time here. Let's go to parcels. So essentially what I want to do, and when this loads, we'll be able to see, but is actually be able to look at the parcel owner acreage by sum. And I can add this widget here. And again, we can go back to our area, and it's going to filter these parcels. Go back to our 5-mile radius area. Again, everything updates. Even if it's not visible on the map, all of these widgets are associated with that data. You should see this parcel information update here. I actually have to delete this. Draw with this. It's going to update. Again, this should update our data. We see that our emissions data is has been excluded here. Parcels should update. I think it's just taking a bit of time because the data set is large. I'll save our workbook. Refresh the map. Again, this widget should update. when I draw a polygon around it. But another way that we can do this as well, say if we're going in the inverse direction, oh, looks like it did. Again, a lot of these data sets now that I have on this widget are got the point set, which is absolutely massive, and then the parcels data sets. Sometimes you just have to be a little bit patient for things to load. But for the sake of time here, I'm going to just show you the last step here because I want to leave a few minutes for questions, and I know we're almost at time. But we could click on specific parcel owners to see where their positions are, essentially to see how easy it would be to amalgamate a single position. And that's what I was trying to show with the area or the polygon tool, was this chart should update with the actual the owners within that area, and how many individual owners would you have to actually approach to get the subsurface, the actual pore space rights. And so this is an interesting inverse approach, is if we started with parcels, identified a landowner with a contiguous position, then looked at pore space under that, then looked at pipelines and emissions, right? There's a number of different ways we could approach this workflow. And so that's looking at the parcels. And I'd say the last piece, again, there's a lot of pieces in this, is looking at what we call our exclusion layers. And so this is looking at things like the presence of canopy, floodplain, slope, wetlands. I'm just going to turn off the parcels layers here because that's quite large. But the exclusion layers, we can turn on all of these. And then we can also look at critical habitat, which is also important for permitting of any of these projects. And so I can color these by either listing, we can color these by common name, scientific name, but that'll all appear on the legend on the side here as well. And so it looks like within this particular area, there's no defined critical habitat, but there is quite a bit of presence of canopy, floodplains, obviously around the Mississippi River, slope, anything over, I believe it's 5 degrees here. Yeah, or sorry, 2.86, slope over 5%, and then any presence of wetland. So any surface considerations or risks that might arise. And so I know there's a lot involved in this workflow, and we've looked at a lot of different data sets. There's a lot more widgets that you can pull in for, say, regional screening of emissions or capture break-evens. But the ultimate purpose of this was to show how we can incorporate those subsurface maps or any subsurface gridding properties with the data sets that we have to create that holistic picture of everything that would be needed involving an analysis for one of these projects. And again, this can be done for other projects, not specific to CCUS, CO2 storage, but for oil and gas production, unconventional, power and renewables. There's pretty almost unlimited options, unlimited number of options that can be done with incorporating your own data with the data that we have.